All right, gentlemen, just to run through the questions that were given in the session last week. We're just going to run through these questions now. So for question 1, we're given a cylinder, or we're told of a cylinder of length. Now, length is the same thing as height. So if you had turned the cylinder the other way and indicated length, no problem. And the radius here is 4 meters. The length is 250 meters and the radius is 4. In the first part, we are asked to determine the volume of the cylinder. Now, the volume of a cylinder is the area of base times the height of the cylinder. So the area is circular, okay, with a radius of 4. Because it is circular, we applied the formula pi r squared, right? And the radius is going to be 4, so we're going to indicate that when we're punching the values. And the height of the cylinder is actually 250 meters. Now, we're going to use pi as 3.14, and the radius is 4, so that's 4 squared times 250. Okay? So this would simply be, we're going to utilize the calculator here. We have 3.14 times 4 times 4 times 250. So that would give us 12,560 meters squared. Now, the volume here is in meters squared. Now, if we're going to convert that to capacity, it's much easier for us to be utilizing cm, all right? So, sorry, it should be cube, cm. So, what we can do, as is suggested when we're doing distance and map, is to convert the meters to centimeters right off the bat, right? So this 4 meters here, if we're going in the route to find capacity now, we can just adjust the calculation for volume. So we have it in meters here, and if I had preempted by looking at the question on capacity that was required, I would have done the conversion here. But I'm going to just come back to this after I've done the conversion. So for this is actually 4, you remember 100 meters, sorry, 100 centimeter equals 1 meter. So I can do the conversion here. We're converting from a large unit. We're going from meters to centimeter, and we're moving from a large unit to a small unit. That means we're supposed to multiply. So this 4 meters here will be multiplied by the 400 to give us 400 centimeters. And similarly, the 250 meters here will be multiplied by 100, and that would give us centimeters. So we have, I'm going to indicate the centimeters right there. So we have the dimensions of the cylinder now in centimeters, okay? So if I were to redo the volume, again, using the formula area of base times height, we just apply the same value. So it would be 400 centimeters, right? We can do it this way, times pi, and this would actually be squared, and times the height, which is that, and that's cm as well. So again, this is the same thing as saying r squared times pi times height, which is pi r squared. So I'm just writing it out of convenience, okay? So this is going to be, just to write it the traditional way, 3.14 times the radius, which is 400 centimeters squared, times the height. Okay, so this would be 3.14, which is pi, times the radius squared in centimeters. This is 400 times 400 times the height, which is 25000, and that would give us 1.256 times 10 to the 10. Now this is standard form, and this is the same thing as 1. So we're carrying 10, we're moving the decimal places 10 spot to the right. So it's 256. Let's see how many we have here now. So this will be 1, 2, 3, 4, 5, 6. Let's check. So from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 110. So the volume would be that value in cm cube. Okay. Now if we're asked for the capacity in liters, well, we know 1000 cm cube is equal to 1 liter. Okay, so all we need to do is to just divide this by 1000 and we're good to go. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And divide this by 1000, of course. You just simply do that. And we have 1, 2, 3, 4 liters. And this looks like 12,560,000 liters. So that would be the capacity of the cylinder. 12,560,000 liters. All right. Now we had 12,560 meter cube here. So basically what this is saying is 12,560 meter cube is the same as that value right there. All right. So what we did here was to simply convert the dimensions on the cylinder from the meters to the centimeters. So 4 meters is 400 centimeters and 250 meters is 25,000. Same, we'll simply multiply it by 100. Now, if you look here, the difference between this value here, we have 1 0 here. Let me just indicate that we have 1 0 here, and we have 1, 2, 3, 4, 5, 6, 7 zeros. Now, if you wanted to go directly from meter cube to cm cube this way instead of going through this long route here, what you would have done is to recognize that the difference is by multiplying by 100, but you couldn't multiply by 100 here to find the value. So if you look here, it's 1, 2, 3, 4, 5, 6, 7. So 6 more zeros are added. 6 more zeros are added. And what happened here is that the 100 was actually cubed. So when you cube that, it's 100 times 100 times 100. And that would simply give you a million. So what we're actually doing is taking this meter cube, which is this, and multiplying it by a million if you want to go directly from meter cube to cm cube without going through this route here. I would suggest that you go through this route, but I'm just showing you how to do that. So you wouldn't be multiplying this by 100, but the cube, 100 cube, which is a million, and then you times it by the value that you got for the meter cube. So if you multiply 12560 times 1 million, you would realize that you get the same value as you got there, which is 12560, and then you added the other zeros here to cm cube. So the long and short of it is, if you're given a solid, in this particular case it's a cylinder, and you're given the values in meter cube, if they're going to ask you for, if you read, this is why it's important for you to read through the question. If you're asked to do the capacity in liters and you know this relationship here, what would be suggested is that you convert the meters to cm right off the bat to have these values ready to be used essentially because when you have the same cube value, you can easily convert to liters, anticipating the second part of the question. But of course, if they ask you for volume, they need to get the volume in meter cube. So you would have had to do this part, because meter cube would have been requested because the original dimensions of the cylinder were in meters. So that's important for you to note. Okay, so the answer for part A should have been this. Okay, should have been this. And they want the capacity in liters, so you'd have to convert the original answer in meter cube to cm cube, okay, and then determine the liter value. Or you could have just moved from meter cube to liters if you know that conversion as well. So it's really up to you to determine what. So I hope persons recognize that this was meter cube, and remember that liters, the relationship between liters and cm cube is this. All right, so I hope persons observe that. All right, which is why it's important for you to scan through the questions before essentially continuing. So I'm going to get this out of the way here. And the second part now is requiring, you get the ruler. Let's get a line drawn here. So the third part, is asking us to find the total surface area, which is part C of the question. Now again, if you notice part D, I'd asked you to find the net. So it would have been good to have the net here right off the bat. So let me just do a sketch of the net of the cylinder here. And remember, this rectangle here, based on one of the lessons that we did, would represent the curved surface area, and of course the circle. So quickly, so the radius of the circle is actually 4 meters. Okay, so the radius of a circle is actually 4 meters. Okay, so we can get those two circles out of the way. So area of both circles would be simply 2 times pi r squared. All right, 2 times pi r squared. So it would be 2 times 3.14 times 4 squared. So of course, let's just run through this quickly. So this would be 2 times 3.14 times 4 times 4. And that answer would be 100.48 meters squared. So that would represent the area of the two circles, okay? And we would need that in order to go about finding the total surface area. So I found the area of that, found the area of that. Now what is required now is the area of the rectangle. Now for part D, it wants to show you that it is asking for you to give them the dimension of the curved surface area. So they want this value here, and they want this value here. Now this value here is already 250 meters, as is indicated in the question. What we need to find now is this distance of the rectangle, and this distance here is going to represent the circumference of a circle. You can go back to that video on cylinder to understand why, if you're not understanding why that is so. Okay, so for the curved surface area, which is represented by the rectangle. Okay, for the curved surface area, we need to know this length, and that is going to really be the circumference. So the circumference of a circle is 2 pi r, and it is simply going to be 2 times 3.14 times the radius, and this is going to be 2 times 3.14 times the radius, and that's 25.12. So this is 25.12, okay, meters, that is 25.12 meters, and that would be this distance here, 21.52 meters. So we can go ahead now and find the area of the rectangle, and then eventually find the total surface area. So area of rectangle, okay, is simply length times width. That's the area of the rectangle. So this would be 21.52 times 250. And of course, that's meters. So let's do this quickly. And this answer would be 6,280 meters squared. So the total surface area would be equal to the area of the two circles, which is 100.48. So that's 100.48 added to the area of the rectangle, which represents a curved surface. So this would be 6280 for a final answer of 6,380.48 meters squared. So that would be the total surface area of the cylinder itself. So again, just to recap quickly. All right, so we're given a cylinder of radius 4 meters, and we have the height of 250 meters. We're asked to determine the volume. Volume is equal to area of base times height, and this is area of base is circular, so it will be pi r squared times the height, or length, which is 250, and this is 3.14 times 4 squared times 250, giving us a volume of 12,560 meter cube. All right, now if you're going to convert the meter cube to centimeter cube, you'd have to understand the conversion here. 100 centimeter equals 1 meter. So because it is volume and volume is cubed, you'd have to cube the 100, which would give you a million, and then multiply this million by the 12,560 meter cube to give you that value in centimeter cube. Okay, that was one way of doing it. The other way would have been to convert the dimensions to centimeter, both radius and length, and then apply the formula, which is pi r squared times height, which is area of base. Again, this would represent area of base. This here would represent area of base times the height, which eventually would give you that volume in cm cube. And when it's in cm cube, you can easily do conversion to capacity in liters, because 1,000 centimeter cube is 1 liter. So you just divide that value by 1,000. That would be the answer in liters, and that's what I hope we got. Quickly, total surface area. Total surface area is in showing the net here. So for part D, just for emphasis for part D, again, just to reiterate, you didn't have to actually do this over. Once you have the diagram here, you're fine. The radius here is 4. There are two circles with the same radius, and this distance is 21.52 meters. Why? Because this distance of the rectangle represents the circumference of a circle, which is what we got down here. And of course, this is 250 meters. Okay, pretty straightforward. So total surface area would be the area of all the faces, the two circular faces, and the curved surface area here. Both circles, the area of both circles would be 100.43 meters squared. Two circles, so it's 2 times pi r squared. And the curved surface here is a rectangle, so we would need to find this length here, which is 21.52, and that would represent the circumference of a circle. The area of the rectangle is length times width. We have one length and one width, or whichever value you want to call length, and it doesn't matter. And that will be the answer there in terms of the area of the rectangle. So to get the total surface area, you'd have the area of the two circles and the area of the rectangle to give you a final answer. And if you wanted to repeat this for part D, that would have been the answer there. So that would have been the solution to part 1.